Okay, this is the last sort of two rules spelled out for you, like with the laws of exponents that we've talked about. These are the last two. We've talked quite a bit about the power one of product, the power of a product rule, but we haven't talked a ton about the quotient rule. So here's these last two for you in a nutshell. Okay, first we have power of a product, and this is where we have two factors inside the parentheses, so something multiplied by something else, and that whole thing is taken to a power. And what we do in that case is we distribute the exponent to each of the factors. So distribute, quote unquote, 'cause it's not technically distribution, but that's what it looks like, is we give that exponent to each factor, including coefficients. So if we have something like AB squared, we would give we'd give that squared to both factors. So the A gets an exponent of 2, and the B gets an exponent of 2. And then the second one is power of a quotient. So this is where we have something that's inside parentheses being divided, right? A quotient. And so to find the power, so to simplify that, you give or distribute the exponent to the numerator and the denominator that is inside the parentheses. So if we had the quantity x over y to the third power, we give that exponent of 3 to both the numerator, so x to the third, and the denominator over y to the third. Okay, here's an example. This would be power of a product. So inside our parentheses, we have negative 1.5 y, and we are taking that quantity to the second power. So what we need to do, because we have multiplication inside of our parentheses, this is negative 1.5 times y, we're going to give this exponent of 2 to both terms, or both factors inside the parentheses. So we get negative 1.5 squared and y squared. And then remember, when we have numbers and variables in our answer, we need to always simplify the number portion. So 1.5 squared is 2.25, and it will be a positive because what this is saying is negative 1.5 times negative 1.5 y squared. And when we do that math, it becomes 2.25 y squared. Okay, let's see if the next one goes on top of this one. Okay, kind of, I'll just work down below. So this will be for our second example. This one says, this will be quotient of powers. The quantity x over negative 10 to the third power. So what our rule says is that we need to give this exponent of 3 to both the numerator and the denominator. So this becomes x to the third over negative 10 to the third. And if we simplify that, we get x to the third, and then negative 10 to the third means negative 10 times negative 10 times negative 10. So 100 times 10 is negative 1,000. And that would be our answer. Okay, here's another example. 3d to the fourth over 2, and then let's give that a power. Let's say that this is to the second. This one encompasses both rules, so we need to do product of powers. So this exponent of 2 needs to go to the 3. It needs to go to the d to the fourth, and it also needs to go down to our denominator of 2. So what we end up with is 3 squared, and then d to the fourth times 2. We multiply the exponents because it's a power of powers. D to the 8th over 2 squared. And then we'll simplify all the numerical values. 3 squared means 3 times 3, or 9. D to the 8th over 2 squared. 2 times 2 is 4. And that would be simplest form. All right, so then let's look at this one. We have the quantity 2x over 3 taken to the negative fifth power. So what we're going to do is use power of a product. Okay, meaning this negative 5 exponent needs to go to both terms on the top in the numerator, and it also needs to be given to our denominator. So we end up with 2 to the negative fifth, x to the negative fifth over 3 to the negative fifth. And then all of these have a negative exponent. So what we're going to need to do is we could deal with each one at a time. Okay, let's bring this 2 to the negative fifth down below our fraction bar to change the sign of the exponent. Let's do the same thing with x to the negative fifth. So bring that below the fraction bar. It becomes x to the fifth. And then down below, this 3 to the negative fifth needs to come up, cross the fraction bar going up in order to make its exponent positive. 3 to the fifth. And then our last step would be to simplify all of those numerical terms. So 3 to the fifth means 3 times 3 times 3 times 3 times 3. So 3 to the fifth is 243 over 2 to the fifth times 4 times 2 is 8. Wait, 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. X to the fifth. And then I don't think those two constants can simplify at all. I don't think so. I think we're done. So 243 over 32x to the fifth. All right, so there's some practice on that. You just have to be really careful with your exponents, making sure you give it to each term, and making sure, especially when you have something like this, and you give that exponent to a constant, you don't multiply it. You don't say 2 times negative 5. It becomes 2 with an exponent to the negative